Ocean Ecology Study Guide. Starting this off at number 1, a minus minus. Now this one is competition. It's not good for either organism as they have to expend more energy to compete for the same resources. Example, this would be a shark and a dolphin competing for food. If the other one wasn't there, it'd be easier to get food, but because the other one is there and they're competing, each has to spend more energy. All right, moving on to number 2, plus plus. This is a mutualistic relationship, also known as symbiosis, but mutualism is fine. This is an example of, like, let's say, a sea anemone and a clownfish working together. Sea anemone gets protection from the clownfish. Clownfish gets a place to live. What about plus zero? This is a weird one known as commensalism. This is where one organism gets a positive and the other one isn't impacted at all. Examples of this include like whales and barnacles. Now the barnacles get a plus because the whales take it from place to place. It basically gets free transportation to food sources. Now the whale is not harmed. It doesn't hurt it. It doesn't help it. It doesn't affect the whale at all. All right, what about this plus minus? Now there's 2 plus minuses, and this one, it depends on how it's explained. Now when one is getting a benefit and one has a negative impact, this is when one organism is consumed. This one is predation. Obviously, it's good for the thing that's eating the organism, bad for the organism that's getting eaten. This could be simply a shark eating a fish. Over here, plus minus, this is when an organism is a host and harmed but not consumed. So this one is parasitism. Again, both are plus minuses. This one is basically dead right away. This one might survive for a while. Examples of this include like fish and isopods. Basically, isopods are like fleas. Put it that way. They're kind of like fleas on fish, where they will consume or eat a portion of the fish, its blood. Bad for the fish because it's losing something, and good for the isopod because it gets a free meal. All right, moving over to number 6. Consumes only producers, herbivore. Consumes only other animals, carnivore. Consumes both, omnivore. Second level, what can it not be? First level, what can it not be? Let's start off with the first level. So what can a first level organism not be? So looking at 6, 7, and 8. All right, let's come over here. Here's a first level organism. First level is eating, okay, is eating producers. So here it's pine tree and berries. So the squirrel cannot be a carnivore, okay, cannot be a carnivore. Look at the deer. The deer, it's eating a plant of some kind. It cannot be a carnivore. Fox, okay, it's at the first level. It means that it's eating plant material. It can also not be a carnivore. So the best answer for this one is it can't be a carnivore. All right, what about a second level organism? Okay, second level organism. So let's go back to this one. So, if I'm counting backwards, 1, 2, in this string, the jaguar would be a second level. This is not the jaguar's highest level, by the way. What can it not be? Look, the jaguar is eating animals. Okay, it's eating animals. The jaguar cannot be an herbivore. So coming back here, it cannot be an herbivore. Why? Why can a second level not be an herbivore? Because it's eating first level, and first levels are animals. Why can first level not be a carnivore? Because it's eating 0 level, or because it's eating producers. It's eating a photosynthetic or an autotroph of some kind. So it cannot be a carnivore. So moving on over to this side. So that was 12. So 13 complex diagrams, food web. Producers are at the base here. They produce glucose for the system. The chemical formula for this is C6H12O6. This is created through the process of photosynthesis. Now this doesn't have a number, but you might want to know it. This energy will later be glucose will later be converted into energy by the mitochondria in the form of ATP. All right, moving on to number 19. Producers are at the base. This includes macroalgae and phytoplankton. Phytoplankton on that one. All right, let's move over to 19. So 90% of energy is lost at each level. Basically, this means that 10% is transferred. Why is energy lost? It's because we all use energy for things. What are the 4 things we use it for? This is in your notebook in parentheses. It is cellular function, growth, repair, and reproduction. All living organisms, even producers, use it for those 4 things. All right, moving over to populations. 2 ways you calculate population size: random sampling or mark and recapture. What do you do when an organism is microscopic or they don't move? Random sampling. Big A, this is the total area. Okay, so total area. Little a, area sampled. Little n, number of organisms in sample area. So if the total area is 100 squares, we don't want to measure 100 squares. We go out and we sample 10 of them. We count up all the things in all 10 squares. Let's just say it happened to be 30. Then we can set up our equation. Now this one right here, 27 and 28, I'm probably going to ask you to play around with variables. If big A is larger than it's supposed to be, what will happen to n? Throw in some fake numbers into the equation, okay? And then in the next one, make big A larger and see what happens to your n. This one right here, set up a fake equation, use some fake numbers. Make little a, or I'm sorry, this one's, yeah, make little a smaller than it's supposed to be and see what happens to your big N. All right, come over here to number 29. So this is usually larger organisms, or the organisms move quickly. Basically, they're not going to stay in your squares or your quadrants. You're going to use mark and recapture. Big M, it's the number you first mark. Super important number you first mark. 31. Little n, it's the number of organisms you catch the second time. Little m is how many of them. Okay, so how many of little n were marked. For 34 and 33, do the same thing. Set up the equation. So this is your big M times little n, parentheses, divided by little m. Put in some fake numbers. See what happens. All right, moving on to number 35. This is the jaguar example, so coming back to this food web. So I'm going to just do this really fast. So I'll show you the longest one. Jaguar would be counting backwards against the arrows. 1, 2, 3. Or it could have been 1, 2, 3. Either way, 3 is going to be the highest level for the jaguar. Coming back over here to this one, number 36, the hawk. What would be the highest possible level for the hawk? So the hawk, just to expedite this quickly, again, some of you might get 2 or 3, but the answer is 4. So again, counting against the arrows, 1, 2, 3, 4. So highest level for the hawk would be 4. So coming over here to number 37, this is just a problem. But what kind of problem? This is a random sampling problem, so make sure you know how to set it up. 38, what percent of your total area should you measure? You're going to want to shoot for 10%. Now, in the video, the guy said 5 to 10. I said 10 to 15. This is a problem that, like I said, if you give me a range between 5 and 15, the answer will be right. The ideal number, though, no one's going to argue with you, 10%. Go with 10%. In order to avoid bias, what should you do? Use a number random generator, okay, or randomize your selection of squares. You don't want to go out and say, okay, I'm going to pick all the little a's. No, use a random generator to select which ones. Number 40, this is a mark and recapture problem. This is that big M times little n divided by little m. So just go ahead and plug it into the equation. Explain why a first consumer cannot be a carnivore. It's eating plants. Done. Explain why the second level could be a carnivore. Well, it's eating animals. If that's the only thing it eats, it's a carnivore. But coming over here, like the fox, okay, it's eating squirrels too, so it could be an omnivore. But for sure, it's either a carnivore or an omnivore. Explain why a second level cannot be an herbivore. So why can't a second level be an herbivore? Because second levels eat first levels, and first levels are animals, so it can't be an herbivore. Like only first levels can be herbivores. If 90% of energy is lost at each level, how do the top trophic level organisms survive? Like you, okay? If phytoplankton or the lettuce used up all the energy, how are you going to survive? Well, you just eat more lettuce. You eat more chicken nuggets, or you eat whatever it is. You keep eating. Last one, this is the one where we set up the grid. Remember where I labeled, number 5 at top, 0 at the bottom. You put in a number and then you move the decimal. That's what this is. So if you had 30,000 at the producer level, what would you get at the third level? Again, you're going to move this decimal 1 2 3 times once you get to the third level. So you would have 30 calories. And that covers the study guide.